Somewhere out there, beyond everything you can see with your own eyes, there are stars so far away that the light reaching us right now left them thousands, sometimes millions of years ago. We look up and imagine spaceships gliding effortlessly between galaxies, jumping from star to star the way we drive from one city to another. But here is the uncomfortable truth. Based on everything we currently understand about physics, interstellar travel might be one of the hardest challenges humanity will ever face, and possibly one we may never fully solve. Yet at the same time, it might not be as impossible as it sounds. By the end of this video, you will understand exactly why traveling to another star is so incredibly difficult, and what real scientists are actually working on to make it happen. Let's start with the number that changes everything. The nearest star system to our own, other than the Sun, is called Proxima Centauri, and it sits about 4.2 light-years away. That means light itself, the fastest thing in the entire universe, takes over 4 years just to travel that distance. Now compare that to our fastest spacecraft ever built. The Parker Solar Probe, humanity's quickest object, moves at roughly 190 kilometers per second. Even at that incredible speed, it would still take more than 6,000 years to reach Proxima Centauri. 6,000 years just to reach our closest stellar neighbor. And that is considered close by cosmic standards. To put this in perspective, 6,000 years ago, humans were still inventing writing for the very first time. That is the scale of time we are talking about with our current technology. So why is speed such an impossible barrier? The answer lies in a rule discovered by Albert Einstein over a century ago. Nothing with mass can travel at or faster than the speed of light. As an object approaches light speed, it requires exponentially more energy to accelerate even slightly faster. Getting close to the speed of light would require energy levels so massive that no fuel source we currently possess, not even nuclear fusion, could realistically provide it. This single law of physics is the reason why simply building a faster rocket is not the solution. We are not dealing with an engineering problem alone. We are dealing with a fundamental limit woven into the fabric of the universe itself. But scientists have not given up. Instead, they have proposed several radical ideas that could make interstellar travel possible, even without breaking the speed of light. One of the most fascinating concepts is called a generation ship. This would be an enormous spacecraft, essentially a self-contained world, carrying thousands of people who would live, grow old, and eventually pass away during the journey. Their descendants, born and raised entirely inside the ship, would be the ones who finally arrive at the destination centuries later, having never known any other home. It sounds almost impossible to imagine, yet the technology required is theoretically within reach of what advanced civilizations could eventually build. Another approach focuses on getting incredibly close to the speed of light, rather than reaching it entirely. One such concept is called a Bussard ramjet, a theoretical spacecraft that would scoop up hydrogen atoms scattered throughout space and use them as fuel for a fusion engine, gradually accelerating over years until it reaches a significant fraction of light speed. There is also the Breakthrough Starshot project, a real and currently active research initiative which proposes launching incredibly small spacecraft, some no larger than a postage stamp, and pushing them using powerful ground-based lasers instead of onboard fuel. In theory, this method could accelerate a tiny probe to 20% of the speed of light, allowing it to reach Proxima Centauri in just over 20 years instead of thousands. Then there are the ideas that sound like pure science fiction, yet are grounded in real, published physics. One of them is the concept of a warp drive, first proposed mathematically by physicist Miguel Alcubierre in 1994. Instead of moving a spacecraft through space at incredible speed, the idea is to bend space itself, contracting the space in front of the ship while expanding the space behind it. The ship would technically remain stationary within its own personal bubble of space, while that bubble moves faster than light relative to the rest of the universe. This does not violate Einstein's laws, because the ship itself never exceeds light speed locally, it is space that is doing the moving. The catch is that this theoretical drive would require a form of exotic matter with negative energy density, something that has never been observed to exist in usable quantities. There is also the idea of wormholes, theoretical shortcuts connecting two distant points in spacetime, allowing a ship to bypass the vast emptiness between stars entirely. General relativity technically allows for their existence mathematically, but keeping one open and stable long enough for anything to pass through would again require exotic matter that may not exist in nature, at least not in any form we currently know how to create or control. So where does this leave us? Right now, interstellar travel for humans remains firmly in the realm of theory rather than practical reality. Our propulsion technology is nowhere near capable of achieving the speeds required within a single human lifetime. However, this does not mean the dream is dead. Scientific progress often looks impossible right up until the moment it becomes reality. Just 200 years ago, the idea of flying through the air would have sounded like fantasy. 100 years ago, landing on the moon seemed like nothing more than a childhood daydream. Today, private companies are already developing reusable rockets and researching next-generation propulsion systems that were considered pure fiction only a few decades ago. What makes this topic so captivating is not just the challenge itself, but what it reveals about our place in the universe. The distances between stars are so vast that they naturally protect us from unknown threats, yet those same distances stand as the greatest barrier between humanity and the rest of the galaxy. Every star you see in the night sky could potentially host worlds we have never imagined, but reaching them may require technology, patience, and possibly generations of human effort that stretch far beyond a single lifetime. Interstellar travel is not simply a question of building a faster engine. It is a question of energy, physics, exotic materials, and human endurance across scales of time we can barely comprehend. Whether it happens through generation ships slowly carrying our descendants across the stars, laser-powered probes racing toward nearby systems, or a genuine breakthrough in warp-drive physics that scientists have not yet fully discovered, one thing remains certain. The moment we finally step onto the surface of a planet orbiting another star will be remembered as one of the most defining achievements in the entire history of our species. But this is only the beginning. The universe still holds mysteries far greater than the barrier of light speed. Mysteries that could completely reshape everything we think we know about what is truly possible. If this expanded the way you think about the universe, hit subscribe and join us for the next discovery, because humanity's greatest journey may still be waiting to begin.